The Marriage of Lumen Lux. This lecture looks at a technology that was invented right at the start of the modern age, in the 15th century. I've already mentioned it in the lectures on the atrium and on the theatre. We call it perspective. Although perspective was a modern invention, it grew out of a tradition of thinking that goes back into antiquity. So, although this lecture is about early modern architecture, I'm going to begin with a quotation from Vitruvius. In the opening paragraph of the introduction to Book 6, Vitruvius writes, "It is related of the Socratic philosopher Aristippus that, being shipwrecked and cast ashore on the coast of the Rhodians, he observed geometrical figures drawn thereon, and cried out to his companions, 'Let us be of good cheer, for I see the traces of men.' With that he made for the city of Rhodes, and went straight to the gymnasium. There he fell to discussing philosophical subjects, and presents were bestowed upon him, so that he could not only fit himself out, but could also provide those who accompanied him with clothing and all other necessaries of life. When his companions wished to return to their country, and asked him what message he wished them to carry home, he bade them say this, that children ought to be provided with property and resources of a kind that could swim with them even out of a shipwreck." Now, the property and resources Aristippus refers to here is the capacity to recognise and to understand mathematical relationships in physical forms, in this case markings in the sand. The human capacity to see mathematical relationships is often regarded as something of a mystery, and of course it has affected the theory and practice of architecture. Now, unfortunately, there are no remaining traces of the geometrical figures Aristippus recognised on the shoreline of Rhodes, so I'm substituting something else in their place. This is a fragment of one of the oldest architectural drawings in the world. It's known as the Forma Urbis. The Forma Urbis is a plan of the city of Rome, dating from around 200 AD. It was drawn by carving onto marble slabs, which were then hung, like tiles, on the wall of a large room in the Temple of Peace. As you can see, the Forma Urbis includes many geometrical figures. The ones I've highlighted in black show a circle and a cross. At this point, I'd like to pause and ask you to reflect on the human capacity to recognise mathematical relationships in material forms. Ask yourself, where are those relationships actually located? Are they out there, in the drawings and buildings that seem to embody them, or are they somehow stored away in the human mind? Or maybe they're in neither of those places, and perhaps it's foolish to think about them as belonging anywhere. Perhaps it's best to think about mathematical relationships as functions or operators that facilitate the capacity we humans have to weave between mind and matter, somehow drawing them together. We can open up the question of the mind-matter relationship by looking at the way philosophers like Aristippus thought about vision. The Greek philosophers thought about vision in two ways. As we shall see, they didn't quite fit together. On the one hand, the Greeks thought about vision as a kind of tie or a link connecting human eyes to real, tangible objects in the external world. Thought about in this way, the act of seeing is like the act of touching. On the other hand, the Greeks thought about vision as a process of projection, whereby the human mind abstracts information from the external world and recasts it as a disembodied form in their imagination. Thought about like this, the act of seeing is like projecting images onto a screen. I'm going to refer to these two different theories of vision as haptic and optic. Vision is haptic, where it's conceived as being touch-like, and vision is optic, where it's conceived as being projection-like. The ambiguity between the two ways of understanding vision carried on into the Middle Ages, but there were modifications. In the Middle Ages, the two kinds of vision became associated with two different kinds of light. Haptic, touch-light vision was associated with a kind of light called lux, while optic, projection light vision was associated with a kind of light called lumen. Each type of light was thought to have its own unique set of properties. Lux was characterised by those aspects of vision that affect our senses, such as colour, texture and shadow. Lumen, on the other hand, was characterised by those aspects of vision that are to do with recognising forms and patterns. Another feature of the conflicting notions of lux and lumen, one that's especially important for the transition into the modern age, is that each one implies a slightly different way of picturing space. The implied space of lux is a dissolved and dissolving medium, immeasurable and dimensionless, rather like a cloud. On the other hand, the implied space of lumen is a harmonic and harmonising medium, infinitely measurable and full of patterns and relationships, rather like music. Turning now to the start of the modern age and to the cultural term we call the Renaissance. One important thing to note about the Renaissance is that it coincided with the time when Europeans began to think of the world as a globe, which is why the socio-economic expansion that began then is today known by the term globalisation. Another important thing to note about the Renaissance is the development of a new technology for making pictures. I'm going to call the new technology by a word you already know but have perhaps never thought of as a kind of technology. That word is perspective. I'm using perspective to stand for an entire system of picture making and not just for the kinds of three-dimensional drawings that we habitually call perspective, although the system includes those too. It was the entire system of perspective that constituted the new technology. It was especially important for the practice of architecture. What was amazing about perspective was the way it seemed to reconcile lux and lumen. Using perspective, it became possible to make pictures that were actually constructed in the harmonic space of lumen but looked as if they occupied the dissolving space of lux. Although perspective pictures were made with a compass and a ruler, the pictures appear to contain human bodies, buildings and other objects that actually looked as if they were made out of the same kind of sensuous materials that such things are made from in the real world. Thanks to perspective, it became possible to depict objects and scenes that actually looked true to life. One consequence of perspective picturing was that powerful Renaissance dukes, princes and popes could have lifelike paintings made of themselves but set within idealised spaces and places. This painting is known as the Montefeltro altarpiece. It shows Duke Federico of Montefeltro kneeling at the foot of the Madonna and Child. The Madonna, with the Child on her lap, is seated on a throne, and the pair of them are surrounded by saints. Notice the way building is brought into the composition. Building, which appears here as the image of an elegantly decorated apse, is used to frame the composition of the human and divine bodies and to reinforce their social and psychological relationships. For example, notice the way the bodies of the saints and angels gathered around the Virgin mimic the shape of the apse, and notice the way the body of the Christ child is draped across the Virgin's lap to correspond to the angle of Duke Federico's crossed hands. And notice the way the suspended oyster egg marks the centre line of the scalloped shell hovering above the Virgin's head. Today, the system I am referring to as perspective is taken so much for granted that it's hard for us to imagine how amazing it must have been for the people who witnessed it first. But it's precisely because we now take it for granted that we need to pause and to look inside so as to see how it works. The construction of a perspective picture requires a minimum of 2 preparatory sets of information, stored as drawings. They are known as the iconograph and the orthograph, and they are made by a process called parallel projection. A parallel projection is the drawn trace of a 3-dimensional body that has been projected onto a flat surface. It's made in the divisible space of lumen. You can see in the illustration in this slide how the iconograph and orthograph are projections of the same body, but each one corresponds to a different orientation. The iconograph is oriented vertically, up or down, whilst the orthograph is orientated horizontally, either on a front to back axis or on a left to right axis. Sometimes iconographic and orthographic projections are referred to as plan, section and elevation, but this terminology is incorrect and misleading. The iconograph and orthograph are strictly luminous projections. The plans, sections and elevations that architectural designers rely on today are only indirectly related to them. In fact, as I have already said, plans, sections and elevations come out of the system of perspective. In a perspective projection, the iconograph and the orthograph are brought together and used to plot coordinated relationships conceived as a matrix of points. The points of the iconographic-orthographic pair are linked to one special point which represents the position of a hypothetical eye. The hypothetical eye is fixed in position. It can't move. It's not like a human eye, nor like that of any other animal. In perspective projection, the position of the hypothetical eye has to be located twice, once on the iconograph and once again on the orthograph. Then, from the position of the eye, corresponding points of the iconograph and orthograph can be projected and fused together. Through the combined fusions of all possible iconographic and orthographic pairings, hard information from the space of lumen is projected into the soft space of lux, where it appears as a 3-dimensional image and can be massaged and manipulated so as to appear both sensuous and geometrical. This is a set of 4 iconographic and orthographic drawings. They were made by the same person who painted the Montefeltro altarpiece. His name was Piero della Francesca. Simple geometric figures are much easier to project in perspective than complex figures. For example, a building lends itself more easily to perspective projection than does a tree or a curtain. Human anatomy is particularly difficult to draw in perspective, and so the challenge of drawing human bodies tended to attract ambitious Renaissance painters like Piero. Renaissance painters rose to the challenge of painting human bodies, not only because it was difficult, but perhaps more importantly, because the people who paid for their services and promoted their careers wanted to see pictures that included bodies and not only buildings. So, although painters like Piero were interested in perspective, they were less interested in how it worked than in using it as a tool for making the new kinds of painting that were becoming increasingly popular with the wealthy dukes, popes and princes who were their patrons. To find the first theorists of perspective, we have to turn to that species of craftsman and thinker who always had been concerned with how systems work, today known as architects. The 2 most influential theorists of perspective were Leon Battista Alberti and Filippo Brunelleschi. Alberti was a very smart secretary. He worked for various cardinals, bishops, princes and popes. Among other things, he would advise these powerful people on matters related to building. Sometimes he would even work on the design of a building himself. This is a picture of the Basilica of Sant'Andrea in Mantua. Alberti designed it sometime around 1470. Alberti was also interested in writing. He was the first person after Vitruvius to write a treatise on architecture. It was called On the Art of Edification. But he also wrote a much shorter book called On Painting, and it's in that book that he discusses perspective. On Painting explains how to draw a three-dimensional object on a two-dimensional surface so that it appears to be foreshortened, thereby appearing true to life. Brunelleschi was a craftsman. He was a master goldsmith and belonged to the Silk and Metalworkers Guild in the city of Florence. But Brunelleschi's activities weren't restricted to silk and metalwork only. He also made paintings, sculptures and buildings. Brunelleschi is most famous for having solved a very difficult building problem, which was how to construct the dome of Florence Cathedral without using scaffolding. This is a picture of the interior of the Basilica of San Lorenzo in Florence. It was designed by Brunelleschi around 1420. Notice how precisely the parts of the building fit together. Unlike Alberti, Brunelleschi didn't write about perspective. Instead, he did experiments that demonstrated how it worked. In the early 1960s, an art historian named Alessandro Peronchi reconstructed Brunelleschi's most influential experiment. You can see him doing it here in this photograph. This photograph shows a male figure in t-shirt and jeans, that's Peronchi, looking into a curious, somewhat bulky contraption which he holds in front of his head and torso. Notice the contraption presents two facing panels. One panel is pressed up against Peronchi's head. It's a painted picture of the view that would be seen by a person standing exactly where Peronchi is standing. In other words, standing in the doorway of Florence Cathedral and looking out across the piazza towards the baptistry. The other panel is held up directly opposite the painted panel. This other panel is a mirror. Now, in order to get to this stage of the experiment, Peronchi had to first make the picture panel. So we need to ask, how did he do that? The answer is simple. Peronchi prepared the picture panel in the same way Brunelleschi did. But how did Brunelleschi make the panel? Well, no one knows for certain. But it is thought Brunelleschi would have used the same technique described in Alberti's book on painting. I should mention Brunelleschi and Alberti were friends and are known to have talked together about perspective. In his book on painting, Alberti advocates the use of an ethnographic and an orthographic drawing of the object or scene to be depicted. As we've already seen, ethnographic and orthographic drawing records geometrical information about objects or scenes. The information is stored as sets of mutually conditioned and conditioning relationships between points, lines and surfaces. The information contained in the ethnographic-orthographic pair can be brought together in an imaginary block of space that is divided into a three-dimensional grid and made to seem as if all the grid lines emanate from a single point, known as the vanishing point. To proceed from an Albertian painted picture to Brunelleschi's demonstration, the vanishing point must be converted into a small hole. This is done by drilling through the back of the picture panel. The demonstrator then looks through the small hole. I hope you can see from this diagram that in so doing the viewer is converting their real eye into the hypothetical eye of perspective. The hypothetical eye can't see the painted picture of the baptistry because it's on the other side of the panel it is looking through. However, because the demonstrator is holding a mirrored panel in their other hand opposite, so the hypothetical eye sees a reflected image of the painted picture. Let's return to the photograph of Peronchi. Now what we see here is just the mid-stage of the perspective demonstration. There is a further third stage. The demonstration is incomplete without it, and yet when people are taught about perspective, that third stage is very often missed out. What Poronki does next is to lower the hand holding the mirrored panel. When he takes away the mirrored panel, he will see an identical view of the baptistry to the one that was reflected there. Only now it is not a mirror image of the baptistry painting, but a direct view of the actual baptistry building. No doubt the direct view of the building appears more vividly than the mirrored view of the painting, but the two views map onto one another. The reason both views map onto one another is because they share the same formal construction. The reason the painted view looks like the direct view of the building is because the information used to construct it was based on the mathematical relationships between the baptistry, the position of the hypothetical eye, and the direction it is looking in. To try to convey to you why all this is still important for what we do as architectural designers, I want to return to the question I posed at the start of this talk, where I alluded to the mystique that is sometimes attached to the capacity of humans to recognise mathematical relationships in material forms. I asked, where are those mathematical relationships located? Are they out there in the drawings and buildings that seem to embody them, or are they somehow stored away in the human mind? What was so effective about Brunelleschi's perspective demonstration is that it went some way toward answering that question, because it showed how mathematical relationships are neither out there in the world, nor are they stored up in the human mind. Brunelleschi's experiment was able to show these things because, as we have seen, in order to get the information to construct the perspective view, Brunelleschi didn't look into his mind, he looked out into the already built world he was living in. But please note, the mathematical relationships Brunelleschi found out there in the built environment arose as a consequence of his human way of looking. The human way of looking involves more than just seeing. It also involves thinking about, or should I say reflecting on, what makes it possible to see. Perspective was important for architects for two reasons. First, because it formalised a process of understanding in which a portion of the already existing environment is singled out and identified as worthy of pictorial representation. Second, perspective was important for architects because it was of interest to a much more powerful social group than people like Alberti and Brunelleschi. As I have already said, perspective was of interest to Renaissance dukes, popes and princes. These people wanted to impress one another by seeing and being seen in the new perspective manner. What made perspective an important opportunity for architects is that they were the ones who understood and could operate it as if it were a kind of machine. Because the perspective machinery links the theoretical truth of a picture to the reality of an actual view, so it is reasonable to suppose the translation can work the other way, and a true picture can be translated into reality by means of building. At the start of the modern age, this remarkable two-way perspectival relationship was responsible for turning the traditional crafts associated with building into the modern scientific discipline we today call architecture.